For most of human history, we shared this planet with other kinds of humans, and the fact that we stopped is not as inevitable as it sounds. There were Neanderthals building fires and burying their dead across Europe. There were Denisovans spread thin across Siberia and into the high-altitude edges of Asia. Homo erectus had already been walking this planet for close to 2 million years before we showed up. And on a small island in Indonesia, a human barely a meter tall was hunting dwarf elephants alongside Komodo dragons. All of them gone now, every single one. But here's the thing about that, it didn't have to go that way. We tend to think of our dominance as inevitable. Like Homo sapiens was always the obvious winner. The species that was always going to end up building cities and launching satellites and arguing on the internet. But that story falls apart the moment you actually look at the evidence. Neanderthals were already living next to us for thousands of years. Homo erectus outlasted us by a margin so enormous it's hard to even process. The Denisovans left genetic material in living humans today, which means they were close enough to interbreed with our ancestors, and some of those encounters clearly worked. These weren't failed prototypes, they were real, functioning human lineages that survived brutal climates and predators and thousands of generations of hardship, and then ran out of luck at roughly the same moment we started spreading. The difference between their extinction and their survival came down to things like population size, climate timing, and whether they happened to be in the right place when conditions shifted. Change a few of those variables and the outcome changes entirely. This isn't really a fantasy scenario, it's a question about biology, about competition, about what happens when different kinds of humans are sharing the same territory with the same resources and very different tools for dealing with pressure. The answer tells you something real about why we're here and why they're not. And it raises an uncomfortable follow-up, which is what the world actually looks like if those variables had gone slightly differently. Not just for them, but for us, for civilization, for everything that came after. So what actually happens if they make it? Neanderthals are the easiest case to imagine because they were already living next to us. For several thousand years, both species shared the same territories across Europe and Western Asia. They weren't separated by oceans or mountain ranges. They were hunting the same animals, sheltering in the same kinds of caves, and apparently finding each other attractive enough to have children together. That last part matters more than it might seem. It means the two species were compatible in ways that go well beyond proximity. So the question isn't whether coexistence was possible. We know it was. The question is what it looks like if it keeps going. What made Neanderthals vulnerable wasn't a lack of ability. Their brains were slightly larger than ours on average. They controlled fire, made tools, buried their dead, and almost certainly had some form of language. There's evidence they used pigment on their bodies and collected feathers and shells in ways that look a lot like decoration. These were not simple creatures running on instinct. What they lacked was scale. Neanderthal groups stayed small and relatively isolated, which meant that when one group hit a crisis, a bad winter, a disease, a collapse in local game, there wasn't much of a safety net. Knowledge and resources didn't travel far. Homo sapiens, by contrast, were already building wider networks, passing tools and techniques across hundreds of miles. That gap in connectivity is probably what tilted things. Now flip it. The climate shifts slightly differently. A few cold snaps don't hit quite as hard. A handful of Neanderthal populations hold their numbers long enough to stabilize. Suddenly, you have two distinct human species moving into the agricultural period side by side. What does that actually look like? One real possibility is gradual absorption. Interbreeding was already happening, and if Neanderthal populations stayed large enough to keep their identity while still mixing with Homo sapiens communities, the line between the two species would blur slowly over generations. There might never be a clean moment where Neanderthals disappear. They'd just become harder to distinguish, folded into a broader and genetically richer human population. But that's the optimistic version. The less comfortable version is that proximity and competition don't stop being problems just because both sides are still alive. Two species hunting the same large animals in the same valleys are going to run into each other constantly. And history, even the history we've written entirely by ourselves, is not exactly full of examples where two groups competing for the same land work things out peacefully over the long term. Neanderthals and Homo sapiens might have coexisted in a state of low-level friction for thousands of years, separate enough to maintain distinct cultures, close enough that conflict was always possible. There's a third option, though, and it's the most interesting one. If Neanderthal populations survived into a world where farming was beginning to take hold, their own trajectory might have looked completely different from anything we can model on current evidence. Everything we know about Neanderthals comes from a period when they were already under pressure, already declining. We don't really know what they were capable of in stable conditions with enough numbers and enough time. A Neanderthal population that made it through the bottleneck might have developed agriculture independently, or adapted to it alongside Homo sapiens in ways that produced something genuinely new. Their physical build alone, compact, cold-resistant, extraordinarily strong, would have suited certain environments far better than ours does. What's strange is that in one narrow sense, this scenario already happened. Most people with ancestry outside of sub-Saharan Africa carry somewhere between 1 and 4% Neanderthal DNA. Some East Asian populations carry slightly more. That DNA didn't come from ancient history textbooks. It came from real people who had real children with Neanderthals, and those children survived, and their descendants are alive today. Some of that inherited DNA appears to have been genuinely useful. Immune genes, adaptations to cold climates, traits that helped Homo sapiens populations survive in environments they were still learning. The Neanderthals didn't just exist alongside us. They contributed to us. In a sense, they never fully left. Most people alive today are carrying a small piece of them right now. Homo erectus is the harder one to picture, partly because they were already so different from us by the time we showed up. Neanderthals were close enough that we had children with them. Homo erectus was something older, further back on the branch, shaped by nearly 2 million years of going their own direction. By the time Homo sapiens was spreading out of Africa, Homo erectus had already been everywhere. They'd crossed into Asia, moved through what is now China and Indonesia, and built a survival record that nothing else in the human family comes close to matching. And they did all of it without the social networks, the symbolic language, or the rapid cultural exchange that we rely on. They just kept going, for an almost incomprehensible stretch of time. Their end wasn't a collapse, it was a slow squeeze. Their last populations ended up on Java, cut off from the mainland, with shrinking forests and a gene pool that had nowhere to grow. That's not a story about weakness, that's a story about geography. Change the geography slightly, leave the forests intact for another few thousand years, give that island population enough room to maintain numbers, and the outcome is completely different. A species capable of surviving 2 ice ages, multiple climate shifts, and a journey from Africa to Southeast Asia doesn't suddenly become fragile. It was the situation that was fragile, not them. So what does a surviving Homo erectus population actually look like? They wouldn't look like us. Their tools were simpler, and they changed those tools slowly, across hundreds of thousands of years. That sounds like stagnation, but it isn't really. When something works well enough in a stable environment, there's no pressure to replace it. They weren't behind. They were stable. A surviving group in Java or along the edges of Southeast Asia would still be using tools that Homo sapiens would have looked at as ancient, while Homo sapiens was busy innovating at a pace that the rest of the world had never seen. 2 very different speeds, operating on the same planet. The question is whether those 2 speeds could exist side by side. In some parts of the world, maybe. The range that Homo sapiens was pushing into 50,000 years ago wasn't uniformly occupied. There were gaps, pockets of terrain that early modern humans weren't filling immediately. If Homo erectus populations had held on in parts of Southeast Asia or along the edges of the Pacific Rim, they might have had enough separation to persist. Not thriving, not building anything that looked like civilization, but surviving, doing what they'd always done, which, for context, is more than almost any other species on Earth had ever managed. The collision would have come eventually, though. Homo sapiens' expansion didn't slow down for Neanderthals, and it wouldn't have stopped for anyone else either. The question is, what that contact looks like when the species on the other side has 2 million years of survival knowledge baked in. They knew how to read environments that Homo sapiens was only just arriving at. They'd been hunting those ecosystems since before our species existed. That's not nothing. That's an enormous depth of embedded, practical understanding of how to stay alive in specific places that our ancestors had never seen before. Whether that would have been enough to hold territory against a species expanding with the speed and social flexibility of Homo sapiens is hard to say. Geography would have mattered more than anything. Separation buys time, and time, for Homo erectus, had always been the one resource they knew how to use. A species that survived 2 million years without us didn't need us to thrive, it just needed a little more space. The Denisovans are strange to think about because we don't really know what they looked like. With Neanderthals we have skulls. With Homo erectus, we have skeletons. With the Denisovans, we have a finger bone, a few teeth, a piece of jaw found on the Tibetan Plateau, and a genetic record that somehow tells us more than all of that combined. There's no face to put to the name, no body shape to reconstruct with any confidence, just fragments and shadows, which makes imagining their survival genuinely difficult in a way the other species aren't. What we do know is that they were widespread. Their DNA turns up in populations from Papua New Guinea to mainland Southeast Asia to the high-altitude communities of Tibet. That's an enormous range for a population whose fossils are rarely found in the ground. Their numbers were probably always thin, spread thin across territory that was vast and, in many places, brutal. High mountain plateaus where the air is too thin for most human bodies to function properly. These weren't places Homo sapiens were rushing to settle. And yet the Denisovans were already there, already adapted, already working out how to survive in environments that should have been impossible. That adaptation piece is worth sitting with for a moment. Tibetans today carry a gene called EPAS1, inherited directly from Denisovan ancestors, that lets their bodies process oxygen at altitudes where most people's systems would start breaking down. That gene didn't come from Homo sapiens. It came from a population that had been living at extreme elevation long enough to evolve a biological solution. A surviving Denisovan population wouldn't just be another group of humans moving through the world. They'd be carrying tens of thousands of years of specialized knowledge about some of the harshest places on the planet, written into their biology in ways we still haven't fully caught up to. Now think about what a living population of them would mean for how early human history actually played out. Their range overlapped with Homo sapiens' expansion across Asia. We already know they interbred with us at least twice, once in a high-altitude population and once in a separate southern group. A surviving Denisovan population, even a small one, would have been visible to the people moving through those regions. And given what they'd already adapted to, they'd have been in territories that early Homo sapiens were only beginning to reach. The ecological knowledge alone would be hard to overstate. A group that had spent thousands of generations in the Altai Mountains or across the Tibetan Plateau would understand those environments at a level that newcomers simply couldn't match. Which plants? Which animals? Which routes stayed passable through winter and which didn't? That kind of knowledge doesn't fossilize. It doesn't show up in the archaeological record, but it determines whether a community survives its first decade in a new environment or doesn't. There's also something genuinely strange about a species we know almost entirely through DNA suddenly being something you could actually meet. Everything about the Denisovans exists in abstraction right now. They're a genetic signal, a data point, a presence we can measure but not see. A living population would collapse all of that into something real. A face, a language, or something like one. A set of tools, a way of moving through the world that we'd have to actually reckon with instead of just inferring from a fragment pulled out of a cave in Siberia. They probably wouldn't have built cities. Their numbers were never high enough for that, and the territory they occupied didn't push toward dense settlement the way river valleys did. But invisibility isn't the same as irrelevance. The genes they left behind are still helping people survive at 15,000 feet. Imagine what a living population of them might have figured out. Homo floresiensis is the one that feels almost too strange to take seriously, until you remember that they actually existed. A fully separate human species, standing just over 3 feet tall, hunting pygmy elephants and dodging Komodo dragons on a single island in Indonesia. Their brains were roughly the size of a grapefruit. Yet they made stone tools, coordinated hunts, and survived on Flores for tens of thousands of years. The strangeness isn't that they existed. The strangeness is how close they came to still being here. Their extinction lines up almost exactly with when Homo sapiens were moving through the region, somewhere around 50,000 years ago. But we don't have direct evidence of contact, no signs of conflict, no clear overlap in the fossil record. What we have is a species that was there and then wasn't. The island itself may have done part of the work. Flores has a history of volcanic activity, and a small population doesn't need much disruption to collapse. A few bad seasons, a habitat shift, a single disease introduced from the outside. A species that had already been squeezed into a small corner of the world simply runs out of room to recover. If the timing had been slightly different, any of those variables could have gone the other way. So imagine they held on, not thriving exactly, not expanding, but surviving on Flores the way they always had, in small groups, hunting the same animals, using tools that hadn't changed much in a very long time. They wouldn't be building anything. They wouldn't be sailing anywhere. The island is the whole world to them, and it has been for hundreds of thousands of years. That kind of deep isolation produces something biology rarely gets to finish. A human lineage that went its own direction for so long, it ended up somewhere genuinely different. And then someone finds them. That's where the scenario gets uncomfortable fast. Because the history of what happens when technologically advanced populations encounter small, isolated ones is not a history anyone looks back on with much pride. It doesn't matter whether the people doing the discovering consider themselves explorers or scientists or settlers. A 3-foot-tall human species living on a remote island in the modern era would not just be a biological discovery. It would immediately become a political one. Who speaks for them? Where do they fit in any legal framework built around the assumption that humans means one thing and one thing only? Every system we've built assumes there's only one kind of person. A surviving Homo floresiensis population breaks that assumption completely. We don't have good instincts for what comes next. What's worth sitting with is that they survived for around 700,000 years on that island before anything went wrong. That's not fragility. That's extraordinary staying power, built entirely on working within the limits of a small place rather than pushing past them. The outside world is what made them vulnerable. A small population on a remote island has survived weirder things. The question is what happens the moment someone sails close enough to find them. Once you have multiple human species surviving into the last 10,000 years, the whole story of civilization starts to look different. Not just politically, but structurally. Agriculture shows up around 10,000 BCE in a handful of places almost simultaneously. We assume that happened because Homo sapiens hit a threshold. Population pressure, climate shift, the right geography. But what if Neanderthal groups in Europe were competing for the same river valleys? Competition accelerates pressure. You don't wait for the perfect moment to settle down when someone else is already farming the land next to yours. The technology question is just as interesting. Homo erectus ran on the same basic stone toolkit for nearly a million years, not because they couldn't change, but because nothing forced them to. Put a population of Homo erectus in contact with Homo sapiens trading networks, and that changes overnight. Pressure and exposure drive innovation faster than isolation ever could. The Denisovans had already adapted to altitudes that shut most human bodies down. That's not just biology. That's accumulated knowledge about how to live in places nobody else could reach. A living Denisovan population in the Himalayas or across the Tibetan plateau wouldn't just be surviving up there. They'd own that territory in ways Homo sapiens never could without borrowing their genes first. And then there's the interbreeding problem, which isn't really a problem, it's a complication. We know it happened. Neanderthal DNA is sitting in most people alive today. Denisovan ancestry shows up across Southeast Asia and Oceania. That mixing happened even when these species were disappearing. If they'd survived, the blending would have continued. And at some point, the category of species starts to blur in ways that make the whole conversation harder. At what point does a hybrid population stop being classified as one thing and start being classified as something new entirely? The harder question is what it does to the concept of being human at all. Every framework we've built around rights, identity, and civilization assumes one kind of human, one species drawing the lines. History is full of moments where we've decided that some group of people didn't fully qualify, and those moments have always ended badly. Now imagine running that same impulse when the other group actually is a different species. Different skull shape, different tool culture, different language structure. The instinct to draw a line would be overwhelming, and this time, the line would have a biological argument behind it, which is the most dangerous kind. Whether that leads to coexistence or conflict probably depends on the same thing it always has: resources, geography, and whether populations have enough space to develop without constantly running into each other. The species that made it this long without going extinct did it by finding niches, not by winning wars. Homo floresiensis on their island, Denisovans in the high cold places nobody else wanted, separate ranges buying separate timelines. But 10,000 years is a long time, and ranges don't stay separate forever. Trade happens, borders collapse, people move. Every war we've ever fought, every line we've ever drawn between us and them, all of it gets a lot more complicated when them is also technically human.